So today we will be discussing mainly on NCERT problems of solid state. So there are various problems, various type of problems. We will be mostly concentrating on numericals. So here is the page number 22. Page number 22. We are starting with problem number 1.16. So here the question is compound formed by two elements M and N. So a compound is formed. I'm not rewriting the question because everyone is having the book, that's why. Compound is formed by two elements M and N. The element N forms CCP. So N forms CCP and M occupy 1/3 of tetrahedral voids. Question is, what is the formula? What is the formula of this compound? Now, since we know that if there are, say, n number of atoms in unit cell, and there are 2n number of tetrahedral voids and n number of octahedral voids. So based on that we are going to solve it. So now see, N forms CCP structure. So if N is in CCP, how many number of atoms are there? There are 4 atoms. So there are 4 atoms. So if N forms CCP and in CCP there are 4 atoms, so in an unit cell there are 4n number of octahedral voids and 8n number of tetrahedral voids for n number of atoms. So here there are 4 atoms. So there will be 4 octahedral voids and 8 tetrahedral voids. Since we know the number of tetrahedral voids already and N is in CCP structure, we can also say that the formula if it was M and N, how many N is there? 4. Because N is in CCP. According to the question, N forms CCP. But what will be the situation of M? It occupies only 1/3 of the tetrahedral voids and there are 8 tetrahedral voids. So the situation for M will be like this. It is 8 into 1/3. Let me make it much more clear. It should be M 8 into 1/3 and N4. So it should be M 8/3 N4. That means it is M8 N12. So we'll take the simplest form. It should be M2 N3. So that should be the formula. M2 N3. The next problem is 1.17, the immediate one. Here you can also read it out. Which of the following lattices has the highest packing efficiency? Simple cubic, BCC, or hexagonal close packed lattice? So for simple cubic, we know it is packing efficiency. We are talking about packing efficiency only. It is 52.4%. For body center cubic, this value goes up to 68%, and for HCP, hexagonal close packing, it is same as FCC, which is 74%. So check these values. This is what packing efficiency. That means how efficiently it is packed. That means onto its 100% of the volume, how much volume is occupied by the atoms itself. So here you see it is highest. That means maximum amount of volume is occupied by the atoms in the unit cell. So obviously, since the maximum amount of volume is occupied, and the packing efficiency for this one will be highest, and it is the most close packed structure among the lot. The next one is problem number 1.18. I am reading it out very slowly. You can rewind the video or you can see the book itself in order to understand the exact question. The question goes like this. An element with molar mass, I am writing the molar mass. Molar mass is 2.7 into 10 to the power minus 2 kg per mole. Forms a cubic unit cell. So it forms a cubic unit cell. So it forms a cubic unit cell with edge length 405 picometer. So its edge length is 405 picometer. So since edge length is given, we can rewrite that it is 405 into 10 to the power minus 12 meter, because it is given in SI unit. So we have converted the picometer not into centimeter but into meter directly. Next is the density is given as 2.7. The density is given as 2.7 into 10 to the power 3 kg per meter cube. Question is, what is the nature? What is the nature of the unit cell? When the nature is asked, we are finding out whether it is simple cubic, whether it is BCC, or whether it is FCC. So these we are trying to find out. That means we are basically putting all the values into this formula, that D is equal to Z into M divided by NA into A cube. This formula is already known by us, D or rho, whatever you can write. Now from here we will find out the value of Z. For simple cube it is 1, for BCC it is 2, and for FCC it is 4. So our target will be, from all these values, let us find out the value of D actually, or the density. Let us see. So let us do that. So D is equal to, so we can convert this. This is Z is equal to D into NA into A cube divided by M. So that we are going to solve. So let us find out the value of Z. So D value, what is that? Density is given as 2.7 into 10 to the power 3. Z is unitless, so I am not putting the unit over here. It is understood. We can understand that the units will cancel each other out. If you want to, you can check it with unit also. Into value of Na, that is 6.022 into 10 to the power 23 into A cube. The value of A is given as 405 into 10 to the power minus 12. So it is 405 into 10 to the power minus 12 meter divided by the value of m, which is 2.7 into 10 to the power minus 2. See, just a quick thought is that here it is kg per mole. Okay, this one is meter. It is a cube actually, so it should be meter cube. This one is mole inverse, and 2.7 in 10 to the power 3, it is kg per meter cube. You see, this meter cube and meter cube is going to cancel out. This kg and this kg is going to cancel out, and this per mole and this per mole is going to cancel each other out. So the unit, there will be no unit. So you have to calculate this much only. Do calculate. Remember, it is 10 to the power minus 12 whole cube. Now do calculate and tell me how much it is. Pause the video and calculate. So after calculating, we are getting it is almost very close to 4. So Z is almost equal to 4. That means we are getting FCC structure for this particular case. So from after in-text problems, let us pay our attention to the exercises. So we will start with question number 1.11. The reason behind choosing this one first, because the previous problems are either very short answer type or it is multiple options are given. So better you start solving from this numerical itself, because we are focusing only on the numericals mostly. So let us see the problem once again. You also read it out. See the book. The question is, silver crystallizes. Silver, it crystallizes in FCC lattice. FCC lattice. Edge length is given. Edge length of the cell, which is A, that is given as 4.077 into 10 to the power minus 8 centimeter. Density is also given. It is 10.5 gram per centimeter cube. You can see the values are given in CGS. We have to calculate the atomic mass of silver. That is what we have to calculate. So I think we have all realized that this problem will be solved by the known formula, which is D is equal to Z into M divided by NA into A cube. Now, what are the values which is already known? D is known. Z, because it is FCC, Z is also known. M, that is what we have to find out. A, given NA, we already know it. So from here, we can write that M is equal to D into NA into A cube divided by Z. Now let us put the values. Now, the value of M will be D, means 10.5. In the previous problem already I have shown you how the units will be cancelled out, but here, since we are not finding out Z, let us put the unit. It is gram per centimeter cube into NA, that is 6.022 into 10 to the power 23. Obviously it is mole inverse, into A cube, that is 4.077 into 10 to the power minus 8 whole cube. If there was centimeter, so it should be centimeter cube actually, divided by Z, that is 4, which is unitless. It is FCC, that is why it is 4. Now here you can see this much and this one. will cancel out. Gram per mole will be remaining because rest of the things are unitless. So now the answer will be in gram per mole. You have to calculate this much. You calculate and tell me how much it is. After the calculation, we are getting 107.12 gram per mole. We all know that silver is nearly equal to 108. So I think we are getting the correct answer. It is the atomic mass of silver which we have calculated, which is almost close to the correct value. Let us solve the next one. Next one is slightly different. 1.12, that is. The question is, there is a cubic solid. It is made up of two elements, P and Q. Here it is written, atoms of Q are at the corners. So Q are at the corners and P is at the body center. What is the formula of the compound? So cubic solid, there are two type of atoms rather, P and Q. P is at body center and Q is at the corners. So how to solve it? Let's see. So to solve it, let us draw how it should look like actually. So this is a cubic solid. Two type, P and Q. So suppose P, I am doing it with red. P is red and Q is green. So Q, all the Q atoms are present at the corners. So these are the corners where Q is present. I hope the color will let you know which one it is. And P atom is present at the body center, which is I have demonstrated as red. So this is the scenario. Question is, what is the formula? So let us calculate here only. We know P is present at the body center. So this one is fully inside. So its contribution should be, how many of these atoms are there within the unit cell? Only one atom. So 1 plus 1, 1 into 1 rather, it is 1. Q, there are 8 Q atoms. Everyone is present at the corner and each one of them contributes 1/8 of that. So the contribution, if I write here contribution, it is 1, and for this one it is also 1. So how many P atoms will be there actually in the unit cell? It is only 1, so it is P. And how many Q atoms will be there? Only one, that is Q. So this is the formula. Formula is PQ. Further it is asked that what is the coordination number? We know the corner atoms are each connected to 8 type of unit cells. So the coordination number of this one, for coordination number of P will be 8. And C, the body center, for Q we are talking about, it is 8 because it is at the corner. It will be in touch with 8 other cubes and everywhere there will be further atoms. So the coordination number of this one is 8. Coordination number means with how many other atoms, other type of atoms it is connected with. And here, since it is at the body center, it is also connected with this 8 type of corner atoms, 8 corner atoms, not 8 type, 8 corner atoms. So for P also, the coordination number is 8. So if it is asked what is the coordination number, the answer should be 8 for each type. And how to find out the formula? This is the contribution. So ultimately there is 1P and 1Q effectively within. So the formula is PQ. Similarly, this type of problems we have solved in the enrichment classes. It will be my suggestion that I will be writing down in the video itself what will be your homework. do follow it. If there is any problem regarding solving those, in the comment section itself you write it down. Where is the problem? I will be solving it over there.